Hello and welcome to Otten Math. In this edition, we're going to talk about 3D graphing and reflections. We'll take some problems and we'll solve them. Right, in the first problem, we're given three different points, and this is in a three-dimensional space. So we have x, y, and z. X comes out at us, y to the right, and then z is up. So we have the point 0, 0, 6, 0, 6, 0, and 6, 0, 0 as our 3 points. And we're asked to find the volume of this figure. Well, as it turns out, this is a pyramid, and the volume for a pyramid is 1/3 base times height. So all we need to do is figure out the base, and we have the height here along the z-axis of 6. So the base is really just a triangle with a base of 6 and a height of 6. So the area of a triangle is 1/2 base times height. I have 1/2 6 times 6, which is equal to 18 units squared. So I take the value of my base, I plug it into my equation, 1/3 base times height. I have 1/3 the base, which is now 18 units squared, times the height of 6, leaves me with 36 units cubed. And that's the volume of this figure. In the next problem, we're given a point H, and I have this drawn out for simplification. We're given a point H. We're told that H needs to connect with x is equal to 2 and then reflect off of x is equal to 2 to k. And we're asked to find the shortest distance as H reflects off of x is equal to 2 to k. So it needs to go from here to somewhere on x is equal to 2 and then back to k. And what we haven't discussed yet, but what I will tell you, is that the shortest distance from H to x equals 2 to k is going to be that distance where the angle that's created, or the line that's created with x is equal to 2, and the angle that's created here, is going to be the same as the angle that's created as it is reflected off of the line x is equal to 2. So the angle of incidence is equal to the angle of reflection. And you will see if you do some experimenting or some algebra that h to this point, 2k, is going to be the shortest distance from h to, let's call this j, to k. Alright, so what we need to do first is create a reflection of k across the x is equal to 2 axis. And that is going to give us a point at which we're going to aim h to k primed in order to get that angle of incidence that equals the angle of reflection that takes us to k. So we find out that k prime reflected over x is equal to 2 is going to be negative 14.7. Well, we know that because we know the distance between k and the x value of k is going to be 16 units from k to x is equal to 2. So as we reflect it over the x is equal to 2 axis, the y value stays the same at 17. But now we just move, again, 16 units to the left. And we end up with negative 14.17 as k primed. So now we have 2 points. We can figure out what the equation is for this line, because ultimately we want to find the point of intersection between x is equal to 2 and a line hk primed. So we find the slope is going to be 17 over 2, which is 15, over negative 14 minus 10, which is negative 24. So we have a slope for hk primed, or k primed h, of 15 over negative 24, or simplified as negative 5/8. Now that we have a slope, we also have a point. We can use the point slope formula to create a equation for the line hk primed. So that would be y minus 2 is equal to the slope, negative 5/8, which we just discovered, times x minus 10. Or simplified, y is equal to negative 5/8 x plus 66. Now that we have the x component, we can find out what the y component is. Now that we have the equation, we can find out what the y component is, because we know already that the point of intersection is going to have an x coordinate of 2. It's defined as this line. So we plug in 2 for x, and I get y is equal to negative 5/8 x plus 66 over 8, or y is equal to negative 10 over 8 plus 66 over 8, or y is equal to 56 over 8, which is equal to 7. So we identify that the point J here is 2, 7. Now we need to find the distance between h and j and k and j. So we use the distance formula to solve. And we see that h to j is the square root of 10 minus 2 squared plus 2 minus 7 squared, or 64 plus 25, which is equal to the square root of 89. So the square root of 64 plus 25 equals the square root of 89. Then from j to k, I have 18 minus 2 squared plus 17 minus 7 squared, which equals 256 plus 100, or the square root of 256 plus 100, or the square root of 356. So the distance between h and j and k is the square root of 89 plus the square root of 356.